We are going to continue our talk about multiplying polynomials in this worksheet, which is going to focus on special products, okay? So I have it written out kind of what special products are. Essentially, when you have a special product, the final result is going to have a very specific format, okay? So we're going to multiply very specific types of polynomials that have a very specific type of product. And this is going to come up again when we learn how to factor polynomials. So definitely pay attention to this section here. But specifically, special products refer to specific patterns or formulas used to simplify multiplication of algebraic expressions, especially polynomials. These patterns often help you expand or factor expressions without having to work through each term manually. And this is gonna, like I said, it's gonna come back when we learn how to factor polynomials, which is kind of like we learn how to multiply polynomials and then we learn how to undo that, which is basically called factoring. Okay, so for topic one, we're going to multiply binomials using the FOIL method. So remember, binomials have two terms. They're polynomials with exactly two terms. And we've already done this. We've already multiplied binomials in the previous worksheet. But for this one, we're going to focus very specifically on the FOIL method. Okay, so FOIL is an acronym and it's used to help you remember which terms to multiply when you're multiplying two binomials. Now, this is very specific to two binomials, only two binomials, okay? So if you consider the following, we have A plus B times C plus D. That's just some generic polynomial, or it's two binomials, basically. So it's just two generic binomials that we're going to multiply together. The F in FOIL represents the first terms. So F reminds us to multiply the first terms of each binomial. So when we look at the first terms, we're talking about A and C. So we would multiply A times C. The O in FOIL represents the outer terms. So the outer terms are going to be the terms on the outside of this product here. So the outside terms would be A and D. So if you think about what we just did, we multiplied the first terms, which is A and C, and then we multiplied the outer terms, which is A and D. That's basically just distributing A through that second binomial. And we already know how to do that. The I in FOIL represents the inner terms. So when you look at these two binomials, we're looking at the two terms in the center, okay? So that would be B and C. And then finally, the L represents the last terms of each binomial. So that would be B and D. So if you think about it, that's just distributing B through that second binomial. And that's how we talked about it in the previous video. You just need to make sure each term in the first binomial gets distributed through the second binomial. And FOIL just helps you remember which terms to multiply when. But you'll get the same answer as long as you just make sure you distribute each term in the first binomial through the second binomial. Okay? Now the final result, if you had A plus B times C plus D, would be AC plus AD plus BC plus BD. Just make sure you watch your signs when you are multiplying polynomials. Okay, so example one says use the FOIL method to find each product, write the answer in standard form. Okay, so for part A, we have x minus 3 times x plus 5. Now remember, we could just distribute each term in the first binomial through the second one. And that's typically what I do when I teach this, but I do want you to know what FOIL means. So we're going to look at the first terms first. Okay, so the first terms in each binomial are both in x, so we're going to apply the product rule, x times x, we keep the base, and then we add the exponents. So this just becomes x squared. Okay, now we're going to multiply the outer terms of each binomial, so that's going to be this x in the first binomial and the 5 in the second binomial. So x times positive 5 is just going to be 5x. We're done with the x as far as the distributing has been concerned, but now we're going to look at the inner terms. So the inner terms are the two terms in the center. So that's going to be the negative 3 and the x. So negative 3 times x is minus 3x. And then finally, we're going to look at the last term in each binomial, which is the 3 and the 5. So negative 3 times positive 5 is negative 15. All right, so we've done the first terms, the outer terms, the inner terms, the last terms, okay, which essentially is just distribute each term in the first binomial through the second binomial. And when you FOIL, a lot of times you are going to need to simplify. So anytime you multiply polynomials, always look to see if you can simplify or combine like terms. So we do have two terms that contain an x factor. And you want at most one term that contains each type of variable factor, and then at most one constant term. So these x's in the center need to be combined. So 5x minus 3x, we just want to take 5 minus 3, which is 2. and then keep the x. So I'm going to keep my x squared, okay? When I simplify my x terms, I get plus 2x, and then I'm just going to keep my minus 15. There was nothing to combine with the squared term or the constant. So that would be our final answer right there. And just make sure you write it in standard form. And remember, standard form is where you write the terms in order, in descending order of powers. So highest exponent all the way to lowest exponent, and then end with your constant. Okay, let's look at part B. So we're going to do the same thing. We're going to look at our first terms. That would be 2x times 6x. So 2 times 6 is 12. Apply the product rule for x times x. So we keep the base and then we add the exponents. So we get x squared. Now I'm going to do the outer terms. That would be the 2x and 1. So 2x times 1 is just 2x. Now we want to look at the inner terms. So that's going to be minus 9 times 6x. So negative 9 times 6 is negative 54. And there's nothing to combine with that x, so we just want to rewrite the x, okay? There's not like another variable factor that we have to use the product rule with. So just multiply the negative 9 and the 6 and then keep your x. And then finally, we want to do the last term. So that's going to be our negative 9 and our 1. So negative 9 times 1 is minus 9. And then again, always look to see if you can combine like terms. And just like the previous example, we do have two terms that have an x factor. We want one term with an x factor. So I'm going to take my 2, subtract 54. That's going to give me negative 52. And then I'm going to keep the x. So I drop down my 12x squared. There's nothing to combine it with. And then my x terms in the middle become negative 52x. And there's nothing to combine with negative 9. So I just drop it down. So there we have it. And again, it is written in standard form. Remember, descending order by powers and then end with your constant. And finally, for part C, we have 3x squared minus 4x times 7x minus 2. So the first terms, we have 3x squared times 7x. So we want to multiply 3 and 7, which is 21. And then x squared times x, we apply the product rule. So x squared times x, we keep the base and we add the exponents. So we just get x to the third. We want to look at the outer terms now. So that's going to be 3x squared times negative 2. 3 times negative 2 is negative 6. And there's no other variable factor to combine with the x squared. So we just bring the x squared down. All right. We are now on the, let's see, first outer inner terms. So that's going to be the negative 4x times 7x. So negative 4 times 7 is negative 28. And then x times x, again, product rule, we keep the base and we add the exponents. And then finally, we want the last terms. So negative 4x times negative 2. Well, negative 4 times negative 2 is positive 8. And then we just want to keep the x. There's no other variable to combine with that first x, so we just drop the x down. All right, and just like the previous two examples, we do have terms in the center that can be combined. We have two terms with an x squared factor. We want at most one term with an x squared factor. So first, I'm going to bring down my 21x to the third. There's nothing to combine with it. And then negative 6 minus 28 is negative 34. And then we just want to keep the x squared factor. So I get minus 34 x squared. And then finally, there's not another term to combine with 8x, so I just drop down my 8x. So when you are multiplying two binomials, you can just think of distributing each term in the first binomial through the second binomial, or you can use this idea of FOIL. So first terms, outer terms, inner terms, last terms, multiply, simplify, and then see if you need to write your answer in standard form.